Let's go and get started by looking at page 273. We have a quiz coming up after we go over the homework, so if you have questions, better ask them now. They had some questions. For instance, number one, what is the probability of an event that must happen?
Outcome.
Well, an outcome is a possibility that could happen, but if something absolutely must happen, for instance, the probability that you will have a quiz here in just a moment. Technically, if the rapture happened, the camera would just keep recording emptiness. Anyway, but barring the rapture, I guess technically that's not a certainty. But anyway, if something absolutely must occur, its probability class is 1. It was actually looking for a numeric, right? 1 is the probability. What about something that could not possibly happen, Ben? That's not one of their questions.
Outcome.
No, what about something that could not possibly happen? What's its probability?
0.
0, right? Because all probabilities class have to be between what two values? 0 and 1. So can you ever have a negative probability? No. Can you ever have a probability over 1? No. Could you ever have a group of probabilities that add up to more than 1? No. What is the sum, it says, of all probabilities associated with an event, Michael?
1.
1 is the sum of all probabilities. What's the name in probability for a possible result? Okay, Ben, back to you for number 3. What's the probability of a possible result called? What's its called? What's the name of something that could happen?
An outcome.
An outcome. There we go. Number 4. This isn't something I emphasized to you, so you would have had to look this up. What is the name for events where the occurrence of one prevents the others from occurring? Jalen? It's a 2-word. Exclusive is a second word. Bryson?
Mutual.
Mutually exclusive. For instance, if I said the likelihood of either Elaine being chosen class president or one of the boys being chosen as class president. Well, you realize if one of the boys is chosen, that means she wasn't, right?
Yeah.
But if Elaine is chosen, well, that means one of the guys isn't chosen. Those two things are mutually exclusive. But if I said the probability of Elaine or one of the girls, well, she is one of the girls. So those are not mutually exclusive. That's not something that we necessarily emphasize this year. Next year, you'll emphasize the difference between mutually exclusive and not. Number 5, in baseball, each at-bat will be either a hit, an out, or a walk. How would we write the probability notation for, letter A, getting an out? How would we write that, Joel?
1 over 3.
Well, okay, they didn't say that it's equally likely each of these things, but they just want the probability notation for getting an out. Griffin?
Out.
P parentheses out would be the probability notation for getting an out. Because we don't want to write all those words, but out is the main word, so we'd say P out. What about the probability of getting a walk? Let's go back to Joel now that he understands what they were asking for.
P, W.
Well, that's maybe a little too vague. We would at least want to write out the word walk, but we wouldn't write getting a walk because that's too long. So we do P walk. What about letter C, getting a hit or a walk? Which is what the major leaguers want when they step up to the plate. They want a hit or a walk. Home run's best, but either of those is still a good outcome, right? Bryson?
P, parentheses, walk, or, hit or walk.
Good, P and then in parentheses, hit or walk. Pretty straightforward there. So again, probability notation means write the little P and then something in parentheses that summarizes the gist of what you're saying as concisely as possible. Number 6, Christian school has 10 first graders, 14 second graders, 18 third graders, 8 fourth graders. Total number of possible outcomes for each of the following events, selecting a first grader and a second grader. If you select a first grader and you select a second grader, how many total outcomes could you have, Corey?
1 to 40? Or 140?
There's 140 different outcomes you could have. Now, selecting a particular first grader and one particular second grader would be a 1 out of 140 chance, but there are 140 different outcomes you could make. You just multiply 10 times 14. What about the, how many possibilities if you select a second grader, a third grader, and a fourth grader? How many possible outcomes could you have, Luciana?
2016.
2016 different possibilities. There, using that fundamental counting principle. Number 7, how many different outcomes could occur from rolling a 6-sided number cube, or a die, twice? Jalen? 36. 6 possibilities on the first roll, 6 more on the second roll makes 36 when we multiply. Number 8, Theo's suitcase contains 3 shirts, 2 pairs of jeans, 2 pairs of shoes. How many different outfits could Theo put together, Kirsten?
12.
12, very good. Number 9, the names of the Great Lakes, Superior, Michigan, Huron, Erie, Ontario, were placed in a hat to be selected. We see a picture of Lake Michigan there. What's the probability of selecting Lake Michigan? Ben?
1/5.
1 to 5. How about a lake with the letter I in its name? What is the probability of a lake with the letter I in its name? Michael?
4 to 5.
4 to 5. The only one that isn't is Huron. How about a lake with less or fewer than 6 letters in its name? A lake with fewer than 6 letters in its name. Joel?
2 to 5.
2 to 5. Very good. Number 10. Anthony Thomas placed each letter of his name into a hat to be selected. Well, how many letters are in Anthony Thomas? I'm counting 13. Did y'all get 13 letters in his name?
I got
No.
13.
I got 10.
I got 13.
Okay, we're consensus is 13. 7 in Anthony, 6 in Thomas. Okay, so he puts all the letters, all 13 of them in the hat. He pulls out, well, what's the likelihood that what he pulls out is a Y? Griffin?
I thought he meant A and Y, but it should just be
What's the answer?
113.
1 to 13 is correct. How about the probability he pulls out an O, Bryson?
2 to 13.
2 to 13, because there's 2 O's in his name, one in the first name, one in the last name. How about the probability he pulls out a vowel, and for our purposes, we're going to call Y a vowel on this one. What's the probability of pulling out a vowel, Corey?
5 to 13.
5 to 13 is correct. Number 11, David said the probability of him getting a B on his next test is 250%. Why is that not a valid statement? Luciana?
It has to add up to 1.
Well, I mean, there's only one probability, so like, there's nothing to add up here. But Elaine, number 11?
250% is more than 1.
It's bigger than 1. You can't have a probability that's bigger than 1. So, because again, what he might come back and say, well, yeah, there's a 250% chance I get a B. There's like a negative 150% chance I get an F. And see there, it adds up to 1. Well, it doesn't matter that it adds up to 1 because you have probabilities that individually are not valid. George said he calculated the probability of a ball landing in a particular circle is 25%, and the probability of it landing outside the circle is 60%. Basketball players, we can think of the circle as the rim. Anyway, but his numbers are wrong, okay? This is not valid. Why not on number 12, Luciana? Could he have a 25% chance of actually putting a ball into a circle and a 60% chance of missing?
I mean, it adds up to 85, and it has to add up to 1.
It has to add up to 1. And the individual, like 25% is a valid probability, so is 60%, but he would have to have something missing. He'd have to have, like, I don't know, the missing 15% is the chance of it landing on the rim. I don't know. Anyway, but yeah, the sum of the probabilities has to equal 1, and it did not. Any questions on the 1 through 12 before we turn the page? All right, let's take a look at the next page here. And we've got a bowl with stickers in it. Have to peel the stick. Anyway, there are 25 car stickers, 30 truck stickers, 10 motorcycle stickers, and 45 plane stickers, as in stickers of planes, not empty stickers. What's the probability of a car or a plane sticker? Let's see, Elaine, you took care of one. Jalen, number 13. What was your answer?
1 to 11.
Ooh, not 1 to 11.
7 to 22.
Not 7 to 22.
Um,
Number 13, what was your answer?
7 to 11.
7 to 11, there we go. Because he's got 25 cars out. Well, first thing you have to do is figure out how many there are. Class, how many stickers?
20. I mean,
Total
110.
110.
I got 110 stickers, right? 110
Yeah.
total stickers. 25 of the 110 are cars. Planes, there are 45 out of 110. And it says class or, so we should add to get 70 out of 110 and then just knock off the zeros. Number 14, let's go back to Jalen, a truck sticker. And you're like, yeah, I don't want the truck sticker. You put it back. And then I'm getting a plane sticker. What's the probability on 14?
7 to 242.
I wonder if maybe you had it and just something's a little off. Kirsten?
27 to 141.
Oh, Michael.
15 to 22.
Oh, the pain. Joel.
135 over 1,210.
Oh, you need to cancel before you do your multiplication. Spare yourself the big numbers. How many truck stickers, class?
30.
30 out of 110, right? And how many plane stickers, class?
45.
45 out of It's 110. Knock off the zeros to reduce here, but we also can take a 5 out. Remember our divisibility rules. This is divisible by 5 to get 9. 110 is divisible by 5. Anyone to get?
22.
22.
And then we can multiply. 3 times 9 gets 27. 11 times 22 is 242. And so, Jalen, you said 7 to 242, and I wondered if maybe you just didn't see the 2. Should have had 27 to 242 for our answer on 14. Question.
I had that, but because the other one was like a denominator of 11, I thought that I was wrong.
Ah, you see, you gotta stop second guessing yourself. It's just reduced down to that. All right, let's go to number 15. And third tries the charm, Jalen. A car sticker, and put it back. Motorcycle sticker. What's the odds? Number 15.
5 to 242.
There we go. 5 to 242 is correct. Number 16. A truck sticker, or a car sticker, or a motorcycle sticker. Basically anything but an airplane. What's the probability? And Kirsten for redemption.
9/44.
Oh, Michael.
I have 13 to 22.
13 to 22 is our answer. Let's look at 16 real quick, and then we'll come back to 15 if we need to. So remember, the truck is 30 to 110. The car is 25 to 110. The motorcycle is 10 to 110. Should have added up to, what is that, 65 to 110?
Yes.
And we can divide a 5 out of both numbers. There's our 22, and there's 13 to 22. And again, show your work. If I can see this work, even if you added wrong and didn't get 65, if I can see this, you're going to get most of the credit. If I can see this and maybe you just reduced wrong, I can give you most of the credit, but make sure you show work on the quiz coming up here in a moment. Does anyone need to see 15 worked out? The answer was 5 to 242. Anyone say, I did not get that, I need help. Questions on 15? Any questions on probability? Ands and ors? Questions on probability? And or. All right, clear your desk except for a clean sheet of paper, pencil, everything else away. Clean sheet of paper and a pencil. Everything else off your desks. Those watching on YouTube, this is quiz 27 we will be taking. Quiz 27. Paper for a cover sheet, pencil, not to throw at the person next to you, but rather to, not to throw at the person next to you, but for the sake of taking the quiz here in a moment. Some people's kids.
You want to throw the pencil at me?
Quickly, Elaine. This row is ready. Good job, row 3. Good job, row 2. The guys' rows were ready to go. Looks like the girls are finally ready. All right, here's for the girls' row. All right, first last name in the name spot, and today's date in the date spot. First and last name in the name spot. Today's date in the date spot today is 4/3/24 as we record. 4/3/24 is today's date. Got some questions you need to answer for numbers 1 through 6. So answer the questions, think carefully about each. And then for numbers 7 and 8, you're going to list the probabilities of those things that they asked. They've given you some information. They're above number 7, number 8. Turn the page. We also continue on to the back. Do not forget to complete the back. That would be very sad. Okay? Flip it over when you're done. Make sure you take care of 9 and 10. Once again, they've given you some information. Make sure you solve for those probabilities on 9 and 10. All right, you may begin. Use that blank page as a cover sheet. Blank paper as a cover sheet, working quietly at your seats. That paper's a cover sheet there, Ben. Once you finish the front side, don't forget to turn it over, work the problems on the back. Once you're completely finished, make sure you cover up your paper with your cover sheet and just rest. It's not asking for an answer, per se. You're not solving anything, you're simply writing probability notation. What you think of it? Take another minute or two, be finishing up. And just rest quietly there at your seat. Once you're finished, cover up that paper.
that's the one I'm going to be putting down final answers.
All right, go pass your papers to the front, if you would please. Pass the papers to the front. I'll grade these tonight, and we will take a look at them tomorrow. And pass those forward, if you would please. Keep it there for now. All right, and if you would go and open up your textbooks to page 274. Page 274 in your textbooks. And with probability in many instances is based not on random chance, but as we kind of alluded to when we talked about football examples and stuff like that, it's actually based on observable past numbers. For instance, if we looked at the odds of my Colts making the Super Bowl, it isn't a 1 to 32 chance. There are 32 teams, the Colts are one of them. The odds of drawing the Colts name out of a hat is 1 in 32. The odds of them winning the Super Bowl goes much deeper. What's the roster construction like? How was their team last year? How does it stack up to other teams and the progress they've made, right? There's a lot of variables that the folks in Vegas, when they're setting odds and stuff, that they look at. That's why it's not 1 to 32 for all the teams, right? The Kansas City Chiefs plus refs. I'm sorry. They've got different odds, right? Then they've got a track record of winning Super Bowls. They've got a track. Never mind. There's some past history going back there based on what's already been observed. Does that make sense? For instance, if I were to say, what is the odds of Michael scoring a goal in a soccer game? Well, we've seen Michael score games in soccer games, so, if he scores a goal, that's pretty believable, right? If I say, what's the odds of Griffin scoring a goal? Well, he plays goalie, so, it's a lot harder for a goalie to score a goal, unless it's an own goal. You wouldn't do that, though. No. So, it's going to be a lot different for him considering, right? And, if you play defender, okay, it's a lot less likely you're going to get a goal. So, we can base things on past history, track record, things like that. It comes down to collecting information. And we see a term on page 274. The term is data, D-A-T-A. You see it there as any collection of facts or information. Page 274. See that term there under Introduction to Statistics? You see the term data. Mark that term if you would, please. Any collection of facts or information. So you get some facts together, you get some numbers, you get some data together, some information together. We call that data. Now specifically, if the data is numerical, if the data is numbers, we would refer to that as statistics. Statistics also refers to, by the way, the branch of mathematics in which data is collected and studied. And you see it there as well. So statistics has two ideas. One, it's a branch of math that studies data, but also number data can be thought of as statistics. If I were to go around and ask all of you your ages, do we see that that's number data? We could say that your ages are statistics. Does that make sense? But if I were to go around and we ask, okay, what's your hair color? Is that going to be a number? No. That's data, but there's definitely no statistic involved there. Does that make sense? Now, if we said, let's see, I would say 4 of you have black hair. Okay, then that's a number now, right? Black isn't a statistic, but 4 people with black hair would be a statistic. If we say we've got 3, Griffin's almost blonde. Would we say he's blonde?
Dirty blonde.
Dirty blonde, maybe Joel sort of, and then Corey definitely blonde. Okay. So 3, okay, but blonde itself wouldn't be a statistic, it'd just be data, but the 3, the number portion to it, for instance, could be. So that's statistics. Branch of mathematics collects and studies data. One of the ways in which you can organize data is in something called a frequency table. You see that term there, and you see an example of a frequency table. 400 different people voted for somebody to be something. We don't know. 400 people were asked, how would you vote? And so these 400 people, 160 of them said John Wells, 108 people said Lisa Williams, 68 said Vincent Otero. And 64 said Frank Brown. That's a good easy name. And interestingly, nobody said undecided, which is usually what most people say when they're called up and asked. Well, they hang up usually. But if they were to answer the phone, a lot of times people say, I'm not really sure. But of the 400 people that gave a name, that's how the voting went down. That's a frequency table. It just lists everything that people said. Statistic sheets are kind of like that, right? Stat sheets are basically a frequency table, if you will. You know, from baseball games last night, okay? So-and-so came to the plate how many times? They had how many hits? How many extra base hits, right? Those are frequency tables in a sense. Now, as frequency tables are constructed, sometimes it's constructed from something that has happened. For instance, Griffin, maybe it's, how many at-bats did they have? This is in the past, it's already done. But maybe it's projection, like it was for this who would you vote for kind of thing, right? Sometimes that would be more the case. It hasn't actually happened yet, it's just sort of a question. Or if I asked you guys, okay, for PE, what sport would we like to play next? Okay. Some of you want to go back to play softball again. We're playing volleyball regardless. But like if we put it to a vote and you got a chance to pick and choose and say what you wanted, right? Then that would be putting out a question to try to seek information, to try to gather data. That's called a survey. So a survey is just a tool to gather data. You see that term? It's not actually a bold term there at the bottom of page 274. But a survey is just a tool we would use to gather some data. There's a couple key terms to know with a survey. If I were to say, I wonder what sport the kids at Grace Christian School like the best. Well, if I ask that question, then what I'm asking a question about is all the kids at Grace Christian School, right? That's referred to as the population of the survey. Now, am I going to have time to go to every single kid in the school and ask them what their favorite sport is?
Maybe.
No, because I'm lazy. Okay, so theoretically, it wouldn't take that long, Mr. You just put it out in a text message to everybody, have them all text back the results. Then I have to read all the results. I'm too lazy for that. Okay, so that would be the population. It's everybody concerned. However, not everybody usually gets to answer, right? For instance, when they sent out that survey, they got 400 responses back. Well, probably it was a bigger group than 400 that they were inquiring about. They only asked the 400 folks. Does that make sense? That's called a sample size. A sample is a portion of a population. Note that term. Population refers to the whole group being studied. This population is the whole group that is being studied. Which person do the citizens of Georgia want to be their governor? Okay? We're describing who all the people in Georgia want. But really what they're going to do is they're going to put it to a vote. And sadly, about a third of the Georgia residents who are eligible to vote are actually going to vote for it. People need to get out and vote. Make sure your vote gets heard. But the sample refers to the people who are being polled or surveyed. In some cases, it's open to anybody. Right? Anybody can come vote. It's just that's the right age and legal resident and all that kind of stuff. But the sample is who actually is surveyed. So for instance, if I go to every class and I just pick two people at random, maybe in this class I'm just front row people, Corey, Luciana, what's your favorite sport? And she's like, I don't have a favorite sport. Well, that would still be documented, no favorite sport. And Corey says, basketball. And then I go to the 8th graders and ask them, what's your favorite? And I just pick a couple people at random. What's your favorite sport? What's your favorite sport? You get the idea. I would end up with 2 people from every class, 2 people from every grade level. If we count K3, K4, and K5 as grade levels also, it'd be 30 people get surveyed. The 30 people class is what we call sample. The group I actually survey is the sample. And then I would take the results from those 30 kids and say, this represents what everybody at Grace Christian School is feeling. Now, how accurate is that? Well, if the sample is only 30, it's kind of a small sample. If I polled 5 or 6 people from every class, I'd probably get a lot more accurate depiction. It'd be even better to actually poll the entire population. That's just not real likely. What if I only polled you guys? Hey, you guys, what's the favorite sport at Grace Christian School? Is that really a good sample? Because I only really picked one group, right? Well, what if all of y'all hang out together, you play together, so you kind of have a basic feel for what you guys like. That may or may not be representative of everybody. Right, so it's important that when taking samples, random samples are used. They have a little example problem here. A survey was given to find the most frequently attended restaurants in the city. All right, so of all the restaurants in the city, what's the most popular restaurant that you would go to? So, who should they ask? Should they ask people with, or women with young children? Should they ask single men? Should they ask people who work in the city? Or should they ask people via email? Well, you realize women with young children probably like, well, Chick-fil-A's closing play places now. I don't know about that.
It's sad.
It really is sad. I mean, I'm like, Burger King's the only place left now.
Some
Favorite restaurant? I don't know. Anyway, single men. Okay, they're probably in a hurry. People who work in the city. I mean, they're in the city. People via email. Not everybody checks their email. Do you see that the third sample would actually probably be the best way to handle the questioning? I just ask people, as you see them in the city, hey, where's your favorite restaurant to drop in on? So there's a good way and a bad way to get together a sample. Yes, ma'am. Yes, you may. All right, so let's take a look, if you would, page 278. And let's just look at some of these ideas behind statistics and data, that kind of thing. And number one, they want us to construct a frequency table. You don't have to do it at your seat. We'll do it on the board here. Read number one for us, though, if you would, Kirsten. On page 278, Kirsten. 278, in the homework section, number one. Go and read that for us.
A librarian observes the number of books checked out for several of the following categories: 40 fiction, 10 biographies, 15 devotionals,
Devotionals. Yeah, it's a book written on a spiritual topic.
20 home repairs, and 25 mathematics.
Yeah, you can tell a math person wrote this problem because, let's be real, 25 people aren't checking out math books from the library. But anyway, a frequency table is really this stupid easy. You write the category. For instance, class, we first write down
40
fiction, and then you write the number next to it. 40. Could it get any easier? The next thing we should write down, class? Biographies. I'm going to abbreviate, and that is 10. The next thing? Devotionals. How many? 15. The next one? Home repair. 20. And the last one? And that was 25. And then at the bottom, we can put a total. How many total books got checked out on that particular day? And so you add it all together, and what, anybody? Call it out? 110 is what I heard. Can you let her in, please? And there we go. That's a frequency table. Now, how does this relate, class, to probability? Well, based on these numbers, what's the probability that a fiction book might be checked out next? 40 to 110 or 4 to 11. There's a 4 to 11 chance of a fiction book getting checked out. You see that? Or what's the probability of a home repair book getting checked out? 2 to 11. Right? 20 out of 110. So you see how a frequency table allows us to see probabilities. Does that make sense? If we were to take a particular batter and we said that he struck out 37 times, and he walked, let's just say 14 times, and he got a hit, let's see, 54 times. And we got the total number here.
Oh,
Yeah.
94.
Say math.
I'm getting 105. All right, 105. All right, then what's the probability the next time he comes up to the plate that he's going to walk?
14 to 105.
So you see how a frequency table can make for probability problems very quick and easy. All right, so the key is you'd have to get the information, right? Now this is something, if this is based on something that's recorded, it's already done, that's easy enough numbers to categorize. Here, okay, these books have already been checked out. It's not projection, it's not asking people, what kind of books would you like to check out? That would be more of a survey. Well, sometimes we want surveys though, right? What kind of lunch would you like served in the cafeteria? Everybody's got an opinion on that. Real food. Anyway, Chick-fil-A. There we go. All right, so anyway, looking at number three. Computer salesman. Computer salesman wants to know what brands of computers are popular. He schedules a telephone survey for Tuesday at 11 a.m. Is he going to get good, clear results from his survey if he does a phone survey at 11 a.m. class?
No.
Probably not. Why not?
People sleep.
On a Tuesday at 11 o'clock? Where is everybody? They better be at work. Now, there are a lot of people who work from home, so we might get those people. But it's not really going to be a random sample, is it? Right? So not the best way to do that sample. What about number 4? Youth pastor wants to know the most popular fast food items for youth activities. So he asked 30 of the teens in his youth group. Is that a good way to do it?
Yes.
Yeah,
Yeah.
actually ask the people in question. So yeah, ask 30 other kids in the youth group. Maybe you have more than that in the youth group, I don't know, but 30 of them give you a pretty good idea of what the popular foods are. Look at number 5. Surveys is used to determine the best ride at a particular amusement park. Looking at those options, A, B, C, or D, number 5, what's the best group to survey if you want to find the best ride at the park? Look those 4 options over, mark the one you think is the best. Look the 4 options over, mark the one that you think would be the best group. Corey, what do you think?
C.
How many picked C like Corey did? 47 people at the amusement park. Now, why not B? I mean, 24 teenagers at the amusement park. Well, teenagers may have a different taste than some of the other people there, right? So you want a more general idea, don't restrict yourself to teenagers. You get a broader view. Also, asking more people always helps. People under 4 feet tall probably can't tell you the best ride because they're not allowed on it.
Yeah.
And 60 people at play, they're not riding the rides. They're at play, so probably don't ask. Or at a play? Oh, at a play. That makes even less sense. Yeah, you're not going to go to the opera house. Excuse me. What do you think is the best ride? They don't care. Number 6. A survey is taken to determine the popularity of sewing among teenagers. How popular is sewing among teenagers? Well, which of those groups would be the best people to ask if you wanted to figure out how popular it is or is not? Bryson, what do you think? How about A? Actually ask 73 teenagers, right? What do elementary students know about it? Knitters, of course they're going to claim it's really popular. And teachers, don't bother them. Anyway. Do we get a little bit of the idea, though, of how sometimes data can be collected? Obviously, once something's in the past, it's easy enough to get data on it. But even projecting to the future and trying to determine probability, right? Sometimes a survey can be used to gather that information. Questions on that? Real quick refresher then. Any collection of facts or information class we call?
Outcome.
No.
Stop it with the outcome.
Frequency table. No.
Any collection of facts or information.
Statistics.
Data. Data.
Oh.
It's just
I
data.
didn't own that.
Now, the study of data is referred to as statistics. Also, number data is referred to sometimes as statistics as well. A list of different data in a nice organized fashion is sometimes called a frequency table. Okay, frequency table. If you're doing a survey, trying to gather information about what could be or should be, not that which has happened, the whole group you're trying to study is referred to as the population. But you usually don't study every single person, right? You go to the amusement park, you aren't going to stop every single person who came. But if you could stop enough of them and ask their opinion, you can get a decent size answer base, right? The group you actually ask the questions to, the actual group you study is referred to as the sample. Okay, the people that are actually questioned. Now, here's the deal. Let's suppose you're at the amusement park. How many have been to Six Flags Over Georgia? Six Flags Over Georgia. Okay, so not a few of you. Tell you what, name one ride you remember.
The roller coaster.
Yeah, which roller coaster? Specific.
I can't remember the name of it.
Can't remember the name of it.
Daredevil.
Daredevil. Okay. All right, Michael, you got one?
I like that Batman ride.
The Batman the ride. Okay. And then I think I saw Kirsten's hand.
I don't
You don't remember any of them? You got another one?
Catwoman.
Catwoman? I don't remember that ride, but anyway, maybe it's there. Anyway, so let's just say we ask people, of these 3 rides, which one's your favorite? And let's suppose 72 people said Daredevil, and 84 said Batman, and 56 said Catwoman or something. I don't know. Anyway, and those are the numbers, right? Well, again, we could come up with a frequency table from that and determine the probability of a person liking this ride or that ride. We could also, if we wanted to, gather data on how many people rode Daredevil that day. And maybe one particular day there were 157 people rode Daredevil. It's probably a really low number, but let's just take it because it's an easier number. And the next first day, 164 people rode it. And the next day, 112 people rode it. And the next day, 273 people rode it. There was a special that day. And the next day, there were 148. That's an 8. It just doesn't look like one. Well, you realize we could gather all these numbers, but we might want to know, okay, on a normal day, how many people? Well, you realize the number is going to be somewhere in the middle of all that, right? Somewhere in the 140s, 150s probably, maybe a little higher, because after all, this number is really surprisingly big, isn't it? As we gather data, as we look at statistics, one of the things we want to know is what's normal. right? What's usual for things? And if we look at page number 279, one of the things we're going to be working on over the next several days is finding what are called measures of center. A good way to put this right at the top of the page is write this: what's normal? That's what measures of center are all about. What's normal? Sure, you had a day where 273 people rode the ride, but that's not normal, is it? You also had a day where only 112 people rode the ride. That's also kind of not normal. That's kind of low, right? These other numbers are all kind of close together. That's more of a normal number. Does that give the idea? And there's different ways we can calculate normal. So we'll be looking at measures of center over the next few days. No homework this evening. We'll continue our study of statistics tomorrow. We'll also look at your quizzes from today in our next lesson. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.